Hi everyone, we're going to use the ratio test to determine whether each series is convergent or divergent. And basically on this one, I need to find my nth term. And if you look at this, I can write this over 1. I notice this is going by odd numbers. We're going by odd numbers here. So my nth term is going to be 2n minus 1. And the denominator is going to be 1 times 2 times ... 2n minus 1. Okay, my next term is going to be the way you write and I'll write it down here. Your next term is all you're going to do is put everywhere there's an n, you're going to put n plus 1. And what that gives you is 2n plus 2 minus 1, which is 2n plus 1, sorry. And the denominator, that's going to give you this one's going to give you the same thing. It's going to be 1 times 2 times ... 2n plus 1. So that's your nth term. And we're going to use our ratio test. Is the limit as n approaches infinity over my next term over my current term. So the main difference is you have the plus 1, the nth term is the minus 1. So we write this out, and you're going to get 2n plus 1 over 1 times 2 times ... 2n plus 1, all divided by your other term, 2n minus 1 over 1 times 2 times ... 2n minus 1. Alright? And now what we're going to do is multiply these two, with complex rational, multiply those two, multiply these two, and I'll do that on the next slide. So you're going to get the limit as n approaches infinity of 2n plus 1 times 1 times 2 times ... It's hard for me to draw dots on here. 2n minus 1, okay, over 2n minus 1 times 1 times 2 times ... and that's going to be 2n plus 1. Alright? And that's going to reduce down to 1 over 2n minus 1 times 2n. And then when you distribute, you get the limit as n approaches infinity of 1 over 4n squared minus 2n. So you notice since as the denominator gets larger and larger, this is going to tend to 0. So that equals 0. So therefore this series is convergent. Okay, the last one is this one. So basically we want to find our nth term. And our nth term is going to be 5 to the n over 1 times 2 times dot dot dot, and the next one's going to be 2n. It's just going to be n because you're just going by n. And then your next term is going to be 5 to the little n over 1 times 2 times dot dot dot, and this is going to be n plus 1. And then we're going to take our ratio test, and that's going to be this is your next term. So it's just going to be this divided by this one. So you get 5 to the little n over 1 times 2 times dot 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 times n plus 1 divided by 5 to the little n over 1 times 2 times dot 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 n. Well, what happens is if you multiply this out, I forgot this is n plus 1. This is plus 1. So that's your next term there. Alright, so when you multiply this out, you can, if we want, let's just rewrite this, because 5 to the n plus 1 is the same as 5 times 5 to the n. So I'm going to rewrite that real quick. 5 times 5 to the n. And what's going to happen is these two cancel. And I forgot to do the limit part, so this will be the limit as n approaches infinity. And I'm going to simplify this. So I'm bringing this up here and this here. This would be 1. And you're going to get 5 to the nth times 5 times 1 times 2 times dot 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 to the n over 5 to the n, and then we're multiplying it by this. We already canceled out that, but I went ahead and wrote it down. So 5 to the n times 1 times 2 times dot 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 times n plus 1. Alright, so these cancel, which we already did. And when you simplify this, because you know that right here, this has also got this times n here. So it's times. It's got the n there from the previous term. So these two cancel out. And you're left with 5 over n plus 1. And when you put a huge number into that, it's going to be convergent. Because the absolute value of r is less than 1, and this equals 0. So that means it's convergent. And we could do one more. Let's do the last one. We've got 2 times 4 over 2 plus 4 times 6 over 4 plus 6 times 8 over 8 plus dot dot dot. And I can need my nth term, and my nth term is going to be 2 to the n, or 2n times 2 times n plus 1, all over 2n. So that means my next term is going to be 2 times n plus 1 times 2 times n plus 2. And the denominator is going to be 2 times n plus 1. Okay, and do the ratio test. Take the limit as n approaches infinity. And you take the previous term, which is 2 times this should have been 2 to the nth, and I wrote this down. So this is 2 to the n plus 1. Little 1. Okay, so we get, sorry about that, 2 times n plus 1 times 2 times n plus 2 over 2 to the little n plus 1. And then the denominator is going to be 2n times 2 times n plus 1 over 2 to the little n. Alright, and if I further this up, we're going to simplify. I'm going to move this guy up here, and I'm going to multiply those two. So that's what I'm doing next. So we have the limit n approaches infinity of 2 to the n plus 1 times 2 to the n plus 2 times 2 to the nth, which is what I did here, over 2n, 2n times 2 times n plus 1 times 2 to the nth times 2. Now, crossing things out, we can, that's why I never distribute it. We can cross some things out, and we're going to get this cancels, the 2's cancel here, the n plus 1 cancels, and the 2 cancels here. Alright, hope I did that right. So anyway, we're left with the limit as n approaches infinity of n plus 2 over 2n, and this can be broken down as the limit as n approaches infinity of n over 2n plus 2 over 2n, which equals the limit as n approaches infinity of 1 over 2 plus 1 over n. We already know that when you take the limit of this, that's going to equal 0. This is a constant, so you're basically getting 1/2 plus 0 equals 1/2. Since the absolute value of 1/2 is less than 1, this is your R, then that means this is convergent. And that's all. Thank you and have a nice day. Bye-bye.